my name is Joaquin Alvarez. I'm 23 years old. I work with a program that the University of Cuenca has called PROMAS, specifically working on a water resources project. I have been recently accepted in an honors program. In the future, I would like to attend graduate school for structural design in the US.
My name is Franklin Lucera. I'm 22 years old. I spend my free time doing research about micromechanicals of granular materials with the Theoretical and Computational Mechanics group at the San Francisco de Quito University. I'm fascinated with the space exploration, and I believe in the future, travels through the solar system and even beyond will be a fact. My dream is to design and build structures not only on Earth, but also in different places, so I can help humanity on its next big step.
My name is Brian Astudillo. Nowadays I am part of a honor program that is designed to guide high-performance students through their research career. I have taught linear algebra and differential calculus as a teacher assistant. Also, I represent civil engineering students at the student committee of my university. Currently, I am developing MATLAB tools to performance check before a nonlinear analysis is done. In the future, I would like to get a PhD in structural engineering, and I am looking forward to help people by applying my skills in the seismic area.
My name is Ruben, and I'm 22 years old. Besides studying, I do research and collaborate with a group called Theoretical and Computational Mechanics in the University of San Francisco in Quito. My focus is in micromechanics of granular materials. And I also was a teacher assistant for multivariable calculus last semester. I have a passion for research, and I'm excited about the structures, and I would like to keep my studies with a master's degree and a doctorate degree about it, especially with computational modeling of the structures.
This is our program. I'm gonna explain to you how to use our program. This program has been made to solve trusses with linear and nonlinear conditions. We have 4 different ways to introduce data. We can import data from SAP 2000. We can draw by ourselves a truss. We can take a photo with our cell phone with a file like this. And we can introduce filling the cells of the interface or open an existing file. I'm gonna open an existing file now. Here we can see the materials. You can add another material if you want. The section, the area of the cross section, the coordinates of each node. Then we define the elements with the initial node and the final node and the corresponding material and section. Then we have the displacement conditions. Here we can assign a restraint or a given displacement. Here we have nodal forces. If there is nodal forces, you can add here. Distributed forces, you can add here. If we have effects of temperature, you can add here, or fabrication errors here. Now if we click on calculate, then the program calculates and give the results here. And here we have the global sniffness matrix. Here we have the displacements and reactions. And here we can choose an element, for example element 5, and it gives the status of the element, if it's in tension or compression. Then we have the longitude and the angle and the displacement and force in global axis and local axis. Also we can generate a report clicking here. All this report is made in Word or PDF. That's it.
I'm going to explain you how to draw the trusses in the program. As you can see, we have a grid. This has infinite extension, and you can go whatever you want with the use of your mouse. So I'm going to show you an example. By clicking, you can add nodes to the truss. And if you continue clicking, it will draw all the bars. If you want to stop a bar and then draw a new one, then you have to press escape. So by pressing escape, you can go to another node and add a new node and then continue adding new bars, for example like this. Then you can press enter to finish your draw. I'm going to show you another method to input the points. So you can also use the type P to add a new point with polar coordinates. For example, I'm going to put a 0.1 bar with a theta of 90 degrees. Also, you can draw by adding an increment. Before the initial point is the point you added right before. For example, I'm gonna put a 0.1 increment on X and a 0.2 increment on Y. You can do that by typing the D. So 0.1 here and 0.2 here. You can also add nodes by entering the coordinates. For example, I'm gonna put a point at the 0, 0 coordinate. Let's better put it on the 2 and 3 coordinate. And by this you can keep adding all your nodes. And once you have finished, you press enter and then you have your system.
We can also import a geometry from SAP 2000. So I am going to show you an example. Here we can use a template to generate a truss geometry. So we have to save our model. If we want to export geometry to our program, we have to export the spreadsheet that is in SAP 2000, and then we are going to read it from our program. So here we have to click in export spreadsheet. It's important to click the connectivity data to be exported, so there can be the coordinates as well as the connectivity matrix. So here I have saved it as geometry. So now we go to our program and click on Import SAP. We find geometry. We wait a little bit, and then that's our truss. Here from our program we can easily edit if we have to change the geometry a little bit, or maybe we want to move some nodes, and then we can apply the loads as well as the restraint conditions. One of the best features that makes our program unique is that we can load info from a picture. What it means is that if we have a truss that is drawn like this, then we can use our phone to take a photo, and then all the coordinates and connectivity matrix will be generated by itself. So now I am going to show you how to do it. We have to click on photo, and then we have to enable our camera. So enable camera. As you can see, now I am recording it on real time. So when you feel satisfied about what you see, you have to click on capture. Here you can see that there is the truss. So now to export, it will ask you to scale the draw. So for example, if we think it will measure 100 units, we set it up like this. And as you can see, there we have our truss in the main program. Once our truss is in the main program, we can set conditions and apply loads. For example, here we have applied conditions. So when we calculate, it shows us that if we have restraints, and this triangle shows us that this node can freely move in the x-axis but not in the y-axis. We can also see the deformation. Here we have it, and we can also have the axial force diagram. Well, we can set the scale.
And last but not least, I'm gonna explain the nonlinear analysis. I have created an example right here to show you. In this nonlinear analysis, we're considering a very simple plasticity model. You only can give a percentage of the elasticity modulus of the material for the fluency of each bar. So as you can see, here's the truss, and I'm gonna give a load of P in the node number 7, only in the y direction, negative y direction, and I'm also gonna give it a load of in the node 8 in the negative y direction. Also, you can include as many loads as you want wherever you want in each node if you want, and you can you can put it by a factor, so it can be a half of P, or it can be 2 times P. You can do either of those. I'm just checking the sections. Okay, I'm just checking all the input is fine. I'm gonna put an area here of 40, and I go ahead and press pushover, and this is loading. It's doing after process, so first it's analyzing all the data, and then it's gonna give us a simulation of the nonlinear analysis. You can see the simulation is right here. This will be this is the range of the elastoplastic range. The test is pushover analysis, and the load P of fluency for the whole truss is 140 tons. You can see these are where the elements are going to fluency, and also we have to select. I have already selected a point of control. I'm choosing this point right here, so I can analyze displacements versus the force be applied. And you can see the maximum force is 140, like I have mentioned it. And that was it about our program. I hope you enjoyed it and you find this very useful. We're also looking forward to keep developing the photo options, so you can take photos of real structures and analyze in real time. Also, we are gonna put into our program beams, which means we can put shear forces and we can include momentums to analyze them as well. Thank you very much.